Okay, I think it is time, and thank you for investing your time into coming. I appreciate it. So here are the plans. So globally, we are progressing towards describing motion of electrons as waves in the class. And by now, it doesn't look too much scary, but I'm scared myself. There are equations which are kind of challenging to solve. And therefore, we are coming to the lab because it will be a shortcut. The plan for the next whatever month will be approximately as follows. So in about a week, maybe a week and a half, we will accumulate enough materials to do first presentations where there will be theoretical material that will equally chop between all attendees, and you will in class just come to the board and make a like 4 minutes PowerPoint presenting some background related to what we are doing in class right now, so that we all agree on fundamentals and we have a record that you can explain what it is. Then in maybe 2-3 weeks, we need also some certifications that we all can do some basic solution of equations with Matlab. And until before we do this sharing of the skills to use the software in class, it doesn't make much sense to do practical problems related to physical chemistry. So the goal for the next couple of labs is just to accumulate some basics. Since it is needed, it is a core of the course, and it will enable projects that probably you vote for later. But there is no hectic and rush. So we are starting everything slowly so that we have confidence. And last time it was just general flavor of the software. Today you'll get more, a little bit more. And problem number one is to make sure that everyone has access. The administration of this room wants to cooperate, but they cannot do things on a short notice. And I found a bypass how to have an access without having it on the computers. So those of you who already installed Matlab on their personal laptops, you're already safe. And for those who didn't, I will make a little demonstration how to get an access to the software if you have just a computer and nothing else, because it is just using your credentials as at NDSU or credentials at other organizations that I want to share. And then, so it should, I wanted to invest maybe 15 minutes in that. It may take a little longer, but after we make sure that everyone has an access to software, we will just do little practice as we started last lab to do replacing calculator with Matlab, doing some trigonometric oscillatory functions. And later on, in about 3 weeks, maybe even longer from now, we will summarize everything we learn in like little units and make set of presentations. But there is no rush and hectic. We'll do it slowly but surely. So any objections or questions to this general idea? Okay, who has Matlab on the laptops? Oh, everyone. What about Josh and Joe? Do you have Matlab on your equipment? You can either speak or...
I do have it.
You do?
Yes.
Okay. What about, thank you, Joe. What about Josh? You can type if the microphone is not
Alright, can you hear me?
cooperating.
Can you? All right.
I do not hear, but I'll
Dan?
I'll try to show so that you all will be a little bit more confident, so that if something doesn't work on the personal computer, if you already have access to Matlab, my little demonstration right now will not make any sense. But just to make you sure and confident that you always have an access to the software, even if you're away from your personal computer, I'll do a little demonstration. And if you have the software, you can just lean back, relax, or do homework in other classes. I just don't want to have it on my shoulder that someone doesn't have an access to software, and we will record it. And if anyone is missing class, they can get it. So share screen. Okay. So in the email that I just sent to you, there is a NDSU page that starts with KB. So if I follow this link, it shows ways to access Matlab on the CCast cluster, which is a small supercomputer here in campus. And they do have a link. They do have a link that tells open on demand. So if I follow this open on demand link, it shows, it basically brings me immediately, if I before typed in my NDSU credentials, to this, it's equivalent to the login into this supercomputer. And if you see here, there is a interactive apps. So among interactive apps, I can click on Matlab. So, so if I do so, it will ask several questions like how many hours I want to run it. So I can put 3 just in case. How many CPU cores and gigabytes. And here I should put my email, and if you probably need to copy this line into the project group to make sure it works. If it does not, I'll do some steps to make sure. So x-ckas-prj-d, they misspelled my name, but it is just they want it for having connection. And then to account whoever is using. And then after I click launch, there appears a window where it like shows compression, image quality, and then I click launch. So after that, they will bring up the Matlab to the graphical window of the computer as if it would be on your desktop. And in this window, one can do same things as one can do on the personal computer. So basically, one can put like 2 + 2 and other things. Okay. So so it is method 2. Method 1 is just to download it. Method 3 is a little longer, but I want everyone to be super secure so that you'll have access to software no matter what. And probably the Lola would appreciate this method at most. So in the Google, I type the MobiX term. And then when I click on the link, it brings, so this is a software to communicate with supercomputers. And then I follow the link for download. It brings me to the next window. And then I select Home Edition, download now, portable. And then if I click, it just downloads stuff. And then if I just open this downloaded thing, there appears a window to interact with any supercomputer. And there one can connect to any remote computer nearby. So example is a little computer located at the Department of Chemistry here at NDSU, NDSU North Dakota EDU. And if you want this option, you need a password that I will establish and communicate privately, not for the record on the broadcast. So after after getting there, one can tunnel to another machine with the command that I'm showing, and there on the new machine, you load module load Matlab, and then you type Matlab, and it will be opening in the command line where one can type in some commands. So I type 2+2, it does work. So any questions on the access? Please confirm if you have Matlab open, up and running with either one of the opportunities and you are ready to use it. Okay, Sibyl? Okay, so those who already, you prefer to download it on the local computer, right?
Yeah.
Okay.
Yep.
Yep, but communicate to each other. Those who already installed it may share some experience. For example, when you go to downloading option, it gives you options to download multiple additional packages, toolboxes. You do not need them. If you select only basic version, and it will be more than enough for the class, and it will save time on downloading. Let me ask Joe and Josh, would you please confirm that you have access to, and Nate, please confirm if you have access to Matlab, or if you don't, let me know if you need assistance.
Well, I have a math account, but I'm having trouble with the installation because the laptop I'm using is a Chromebook, which means that the math doesn't work. And so, but I have the other computer which I'm trying to install the math on, but I'm having trouble logging in. with that computer. So I just
Okay.
need some more
Okay.
time to install.
I see. I see. Nate is downloading it right now, and Joe, do you have Matlab up and running, or you also need some you downloading or need assistance in making up and running?
I'm still needed to download it, but I'm working on it right now while I listen.
It should be louder. So, Joseph, Dieter, would you please confirm if I didn't hear, you can type or say.
Confirm what now?
If you have Matlab up and running.
Yes, I do.
Okay, thank you. So we have, I apologize for delay, but we'll better wait for everyone so that we will be on the same page. So I'll check how close Sibel is to it and then go to those who are online. Did it finish downloading? Should it be downloads or you know better where you did or you brought it? Mm-hmm. Yeah, you have it. Very good. Okay, Josh, would you please share screen just that I see how far you are in the installing? I've made you a co-host. It should be just one click. So if Josh is not sharing, Nate, are you close to? I have to install it on different computers since I'm using Chromebook. Yep. Okay. Okay, just a minute. Okay, yeah, thank you. And there will be options to have several packages. You do not need. You need only the main part. Yeah, you did very wise by selecting only main package. Otherwise, it would like download for another 40 minutes. So if by some reason you do not like how we go over these materials in class, there is this attached manual, and basically I will cover some of the things available here, but you can use it as a second opinion or just independent. We need this tools and skills just to get closer to the material in the class. So while we are coming to the same page, and I see at least Sibel is, she doesn't need to share screen for me to see what is going on. So it's like 27% ready. So it may be another, I wouldn't be optimistic saying it is 1 minute, but it's like maybe 5-6 minutes more. Oh, okay, Nate has it open. Joe has it, and we just waiting for Sibel and Josh. So I will just sketch a plan, and then we'll go through a couple of exercises. So maybe last time we all. I just, if I bring microphone close to speaker, it will be back up. So maybe first thing is to have it as calculator. Later, I think it is. It will be not for today, but Matlab is designed to work with matrices. So we will, maybe when we meet on the next week and when everyone will be happy, we will go matrices starting with vectors, and for them one should also like add, subtract, multiply, and then instead of dividing matrices and vectors, there are a couple of operations, procedures that will be needed and which you may have seen in your linear algebra class if you took one. I'm yet bad with names. Let me try. Ellison?
Yep.
Oh, I got it. Did you have linear algebra in the past?
Yep.
Oh, how good, how nice. So For linear algebra, we need to inversion of the matrices, right? The solution of linear equations where matrix times vector is another vector, right? And there will be a so-called problem of diagonalization, right? How do I write it? Right? So we will need to get to it. And in between, we will need the, we already studied it last time, but functions, the ways to visualize them, like graphics, and then numerical differentiation and numerical integration. So this will keep us busy for today, next Wednesday, and then we need at least one more for number 3. We need some basics in programming. We shouldn't get scared because it will be very, very basics. We are not going to write codes. We are going to utilize pre-made codes and just change a couple of lines. But we will go on to save and load data. We will need to loop mathematical procedures. And of course, everything is for writing scripts. And maybe the best fun is how to make videos. Okay, yeah. So this looks like a tentative plan, and I have it typed somewhere. I'll probably distribute it later, but it's just tentative plan for 3 labs. And then after we are done with them, we chop these materials between class attendees, refresh them by presenting, and after we are done with it, start actually applying it to problems of physical chemistry. And I hope it will be fun rather than boring. Okay. So, and somewhere in between, there should be, maybe here in functions, there should be complex numbers. So if I want to focus on vectors, which is premature, I can set up like a variable x and set some value, right? And then I can use it as variable. And if I type size of this x, it will show it is. So Matlab thinks about any data as matrices. And if you have a single variable, single element, it's considered as matrix 1 by 1, right? So if I type rectangular brackets, like 1, 2, then it will be a minimalistic vector. And if I type size x, it will show that it is a vector with 1 row and 2 columns. Which vectors do you like better? Rows vectors or column vectors? Or you hate them both? Any preferences? I like column vectors more. Why? Because if you practice matrix by vector multiplication, then you put matrix first, vector second, and it should be column. So there is an operation apostrophe prime, which converts row into column or back. So let me invite you to just do this little couple of exercises, and I circulate over your seats and check if you feel comfortable with it. It shouldn't be any problem. I'm confident in you, but it's better to see it. And then I will, from time to time, I'm going to ask those who are on Zoom to share screen and show what you are doing. So please be prepared. And if you do not feel comfortable, then type it explicitly, like I do not like sharing my screen, so that I can plan accordingly. Almost. Okay, did you try to transpose to? Okay, good. And now and in the future, in this lab and class, I strongly encourage everyone to talk to each other. So you're not competitors, you are colleagues helping each other. So if something doesn't work, do not wait until I have time. Just chat to your neighbors or type question in the Zoom if you are. So when it will be time for like assigning credits and grades, there will be a way to give some individual tasks. But there are a lot of tasks where we should cooperate.
I just cleared it. So is it
Just
says
type.
brackets, right?
No,
Or
just type X, enter. Interesting. Type X prime. Prime, not double prime, single prime. Okay. Can you type size X but with curly brackets, not it's shift 9, shift 0. X. Enter. Okay, good. Yeah, everything is good. It's very. Do you have your command? Okay, yeah, excellent. So I'm going to stop sharing for a second and ask those who are in the Zoom if you're comfortable to share your screens. And I have the fear that someone will decline, so I will just count on until like 10. If you do not reply, it means you are not comfortable. So Joseph Dieter, would you like to share your screen? You don't need to reply, just go sharing. It's okay. Everything is great. So the meaning of the round, rectangular, and artistic brackets is different. So you realize it yourself. So the rectangular are used to set up matrices and curly as an argument of a function. Okay, yeah, very clear. Now
I can start sharing in a second. Sorry, I just had to get the thing set up.
Okay. Nate, would you like to share screen? So I'm. Oh, instead of Nate, it is Joe once again. Okay, yeah, I see. All exercises you're showing looks right. Oh, okay. So it's just flipped. So next will be everything is good for. Would you be feeling comfortable to sharing your screen? Yeah, I'm answering to typed question of Joe. I did switch off the microphone, I think automatically when I went on a short break to answer phone. So, Josh?
I think he sent a message, one of the ones earlier that said he can't share. I don't know. Like,
I mentioned before, but the Matlab, I was able to get it open, but it's on a different computer. It can only run on Windows apparently, so I have it on my Windows laptop, but the Zoom that I'm currently on is on my Chromebook.
Okay.
So, and since they're on different computers, I can't really share my screen.
Okay, that's fine, but we'll wait until next exercise. We need communication so that I can see what you're doing, and maybe while we go to next exercise, you try to run Zoom on your other computer.
All right. Now that I have it installed, I would be able to be prepared for next time.
Okay.
All right,
Yeah.
right.
Yeah. It would be. Yeah. Thank you. Thank you.
Yep. Sounds good. Sorry about that.
That's okay. That's okay. We all are progressing really quick, and there are much less unexpected difficulties than I was expecting. Okay, so when it will be next round, we'll I'll ask everyone in Zoom to share screen one after another, and let's go to the next exercise, whatever it will be. So functions. We will get back to vectors and matrices in details maybe next meeting, but now let me. So what if I set the x variable as like 1, 2, 3, 4, 5, 6, 7, like several numbers? So it will create an array of data, a raw vector with a little bit more elements, right? And I can do the command to plot this data. X. And if you have Matlab installed directly on your computer, it will be instantaneously. If you connect remotely, it will just make a little delay. So 7 elements, and it's just a linear function, right? If I want only the data points, I can do comma, apostrophe, O, apostrophe. Then it connects them. Or I can do both line and symbol. So basically, it's just data points only where I have the circles, but the spaces between them are connected by line to guide the eye. So please let me know if this little exercise makes any difficulty, and I hope not, and I'll continue. So when we have just few numbers, we can watch them on the screen. But if we need mathematical functions like sines, cosines, exponentials, we need to set up the discrete values for the argument, and they should be not like 1 and 2. They should be tiny fractional numbers in between. So of course I can pretend that I am silly and type like 0, 0.1, 0.2, 0.3, 0.4, and then it will be like densely sparse points. But you see, it's not the right thing to do. It's so one can set the initial, column, and final, and then it will space. And one can put another column and put there the increment. So from 0 to 10 with 0.1 increment, it should be like 100 points. And if I hit enter, it will populate the whole screen. So if I do not want to garbage my screen, I put a semicolon at the end, and it shows the data are inside, but they just do not bother me with how to say, garbaging the screen. And I can double check what is inside my variable. I can type size x, and it should show that it will be 1 row, but like 100 columns, 101, because we start like from 0 rather than 0.1. So if I plot this updated thing, it shows much more circles, and maybe I can even do no circles. So please try repeating it, and I'm not making visits because it seems simple. So I'll do just one more step and then visit with everyone. Yes? Yeah, look at me. I hit enter, and it brings little circles here. So data points. So if I do not do it or do just dash, it makes a line. I can do maybe dashed line. Or it disconnected me. Failed to connect the server. What's wrong? Better. Oh, it even gives me sounds. Good. No, it doesn't. I should learn more about sound. Okay, so from 0 with step 0.1 to 10, colon, quote x, which will be a linear function. And now the next little exercise to put x comma x squared. What should come in the figure? If on the x, yeah, so it should be a parabolic, right? So it doesn't work. Why? Because Matlab needs periods to make difference between vectors and numbers. So if the array is treated only as a set of numbers, it needs period. Okay, now it's time for me to make visit. So I will visit first those in class and then ask those online to share screen one after another. Is it okay to stop sharing? I think there is not much smart things you can reproduce it by typing. Maybe I gave you bad advice on figure toolbar. Maybe one needs to reinstall that figure toolbar. Yes, it was not smart from my side. Maybe this figure toolbar needs to be selected as well. But other things are working fine. Okay. Yep. So you can do different interval. So communicate to each other which toolbar. Did you use all toolbars or only selected?
I think just Matlab. Based on what I did, I think.
Just talk to each other. Okay. So let's arrow up. Yep. And now put period in front of power.
Period.
Period, yes. Now let's work on the. Make sense?
Yeah.
And now let's reset x. Just do arrow up a couple of times where you, yeah, one more. Yeah. So arrow up and then start it from 0 or from -10. Minus 10. Another column. And then 0.1 to have a fractional. Just point. Yeah.
And then
And,
enter.
and now arrow up a couple of times to plot. Arrow up. Yeah, enter. in, so it's okay.
Yeah.
Okay, very good. So if you do not like when this data garbage your screen, you can put semicolon at the end of your.
Not plot them. Different.
Window. X period power shift 6 2 close bracket.
What does the period do?
It tells that Matlab shouldn't think of this enter. And let's look on the. So it works. So period means to Matlab to process the array of data element by element. And if you do not put period, it will treat each symbol as a vector or matrix. So if you want to use just basic mathematical operations and functions, we should put period. Okay, so let me ask everyone on Zoom to share one after another. So Joe, would you like to? Joseph Dieter, I will give the full name because there are two names starting with the same 3 letters. So Joseph Dieter, please share the screen if you feel comfortable.
Yep, 1 second.
And for sharing screen, I think we all use Zoom frequently. So when you click share screen, it gives you option share one window, share another window, or share the whole desktop. So if you show desktop instead of one window, we will see your graphical stuff as well. So you may stop sharing and then share over once again.
Okay, let's see if this works.
Yeah, click and bring the image to the. Okay, yes, very good. Yeah, thank you. You can stop sharing and we'll go to the next one. So Nate, would you like to share screen? Thank you. Okay, yeah, everything is perfect. Thank you. Sorry that we did it so quick. Yeah, you can stop sharing. Joshua Thielen. Josh, would you feel comfortable sharing screen? Did you run? Oh, if you would have started Zoom on the other computer, you need to. I would see you. Your second. You would appear 2 times. Did you start, Josh? Did you start Zoom on your other computer where you installed Matlab?
I installed Matlab. Yep, I was able to get it, but do you want me to just leave the Zoom call now and then sign back on it on my other computer?
Yes, I want you to join Zoom meeting from the computer where your Matlab is running.
All right, I'll just need a few seconds, but I'll do it.
Okay. So we'll wait a little bit so that everyone stays on the same page. And we shouldn't exhaust everyone here today. We'll use limited time. So we got functions and graphics, at least some basics, and the remaining time we should give to complex numbers, maybe plotting imaginary exponential. Plot exp of I times x. And it should be, there will be some tricks like plot 3 x comma exponential, and it is, if you try doing it right away, it will not work. I'll tell what to do so to make it working. And then we will do differentiation and integration, and I think it will be enough for today. So still there is only one Josh. As soon as he runs Zoom on other computer, there will be another participant in the meeting.
All right. I'm just trying to find a way to get the screen to be bigger. I had to.
But
Yeah, but I just need to make sure that the Zoom screen is bigger, because right now it's just a small window on the side. Oh, there we go. And now just, yep. Yeah, I don't know why the y-axis changed, but
okay.
yeah, I thought for mine is like somehow it goes from 0 to 50 to 100. Although I think before it was just going 1, 2, 3, 4, 5. So I might have to just try something again.
Is there another window? Oh, okay. So will you please tell, I see that all typed commands do work, but for graphical things, please tell how were you starting Matlab? Did you install it on your computer, or you just you were running it on the other server?
It's online.
Okay, so is it online on NDSU facilities, or I see you use Matlab MathWorks? So you are using it on NDSU facilities, on some general facilities?
Yeah, I'm using it in the US. And I use my NDUS accounts to sign in.
Okay.
Because I tried doing it with the NDSU, but I had trouble with that. Somehow it worked with the NDUS.
Okay. Would you please stop sharing and then share your whole desktop so that I quickly look what is going on for the whole computer? It looks like you're sharing only the browser window. Would you please stop sharing and then start sharing over selecting not one panel, but the whole desktop, the whole screen?
All right. I'm just sorry. I'm just trying to figure this out. I'm trying to. I'm sorry. I'm having trouble.
Do not worry. Do not worry. It's okay. Can you stop Zoom sharing?
I think the problem is that I can't go back to normal with the Zoom. I'm trying to figure out how to get back to the normal full screen, but I can't for some reason.
Okay. So would you? I think it is okay for now. But what are your plans for the next Wednesday? Would you come to the lab in person?
I think I might have to. I think this time I think I prefer to use to say just use Zoom because I need the Ethernet to connect to the Ethernet so I can have internet connection. Having trouble connecting this computer to the Wi-Fi.
Mm-hmm.
So I mean, as long as I'm able to connect to the Ethernet, then I should be good. But I don't know how that would work in the classroom.
Okay. So you may consider coming to the lab next Wednesday in person.
Possibly.
Good, good. Okay, so please keep trying doing all exercises we are doing in class, and we need to go to the next little exercise so that we do not sit here too long. You may
All right.
stop, yeah, okay, thank you. You may stop sharing.
Yep. I'm trying to stop sharing, but I am having trouble. So maybe you have to find a way to cut me off.
Okay, I'll, Lola, you are in class and you are looking on Zoom. Does it share my screen now?
Yep, I see your screen. So I think what I might do is just see if I just do
Okay,
that.
then let me see how I can participate.
I mean, this point, all you really do is leave the meeting and come back in.
Yeah, it is a good.
Yep. Yeah, I'll be back. So.
Stop participants sharing.
All right.
Okay, yeah, I think.
Yeah, I think everything went back to normal. It's
Uh-huh.
just
I see.
this somehow couldn't do it by myself. And
Okay.
thank you very much.
Oh, not a problem, not a problem.
And again, sorry for the difficulties.
Do not worry. I was expecting that some difficulties will appear, so it's quite normal. Every year something doesn't work from the first time, and it is the reason why we try to meet interactively. Okay, so let's go to just next little set of exercises. So what if I put plot of cosine x? So it should go on oscillating, right? And what would happen if I plot 2 times cosine x? Any expectations? What should pop up if I hit enter? Can you tell by words? So cosine is always cosine, but fringes will be the more distance from each other or closer to each other. How the period will change. Closer, correct. So higher frequency means closer fringes. If I put 0.5, then it will be more Spartan. Okay. What if I put, oh, let me redefine x so it will take negative values as well. So you will go from -10 to 10, -10 to 10. Okay. What if I plot the exp of x? So it should be continuously growing function close to 0 for negative values and going very high at positive, right? What should I get if I put exponential of negative x? Just mirror flip, right? Okay. Now, if I do have imaginary unit, what should happen if I put I times x? I expect it should be an error, or it shows some reprimand telling imaginary part ignored. So it shows, let me show how to put, if you put like x, cosine x, comma, cosine x with red dashes. So it does coincide with this, what I've got by imaginary exponential. But you see, it gives this little imaginary parts are ignored. So it's we know that exponential has real and imaginary. And if we put like argument function, then it will be 2 lines on the plot, right? So how do we extract real and imaginary portions from the complex number? If I tell z equals 1 plus I, or 1 plus 2i. So if I apply the command real z, what should I give? Real part 1. Right? What if I type imaginary z? Correct. Now, if I use arrow up to get to this previous thing, and here I type real of the exponential I times x. So the figure stays the same, but there is no error message because I'm plotting only real part. And by the way, if I type exp I times x, it will show like a set of numbers which all contain real and imaginary part. So what if I put here imaginary? What do you expect? No, something. So imaginary part of exponential is sine. Remember Euler equation. And now we see this offset of sine and cosine. We can, if you put here sine x, comma, then they coincide back because imaginary part of exponential is sine. And what I can do here, I can type here the real I times x. So I plot the function of imaginary exponential, but since we have only two-dimensional plane, I plot real and imaginary. I have forgotten exponential. exp. Yep. So it is same as sine and cosine function. In some sense, we are supporting Euler equation. Make sense? Or there is, feel free to ask questions if you do not feel comfortable. And I will make a visit to everyone soon, but please try to repeat these commands and make sure they are running well on your screens. So maybe I'll make visits right now so that we do not go too far and everyone feels comfortable. Oh, it does work. Okay, yeah. You found a way to run it without installation. Excellent. I'm happy. Yeah, great. Okay, yeah, that's great.
Sorry, they're just a little small there to see.
Oh, let me fix it right now. Or if I can. Maybe I cannot. There should be preferences. Somewhere there should be fonts. Font 18. Bold. No, it didn't work. Let me try it once again. Maybe we need to preferences. Font. Maybe there is a little.
You have to go down and save it.
Okay.
Oh,
Apply. Okay. Yes.
okay.
Right. Yeah. So it's better.
Yeah, better.
Yeah. Thank you for giving a signal. Excellent. Let's watch. I do not. Real, imaginary, exponential. May I try type
Yeah, go
something?
ahead.
I do not see any errors, but maybe do them by pieces. 1, 2, 3, 1, 2, 3. So number of brackets is. Oh, So when you were trying this with x, after we need to redefine, we use the same variable for different things.
Oh, okay. That makes sense.
Makes sense? Okay, and now I suggest we make visits with those who attend on Zoom. So I stop sharing screen. Joseph Dieter, would you feel comfortable sharing screen?
Yep.
Okay, excellent. Yeah, thank you. You can stop sharing. Nate, would you feel comfortable sharing screen? Excellent. Thank you. You can stop sharing. Josh, did you solve the Zoom aspect? You can. Oh yes, perfect. I'm so happy. It works. It works at your side. Yes, you can stop sharing. Everything works fine. Yeah, thank you. So what do we do next? This is okay if we are meticulous mathematicians, but it doesn't look visually appealing. So let me offer the following thing. So I'm just modifying this line. I'm removing maybe just, yes, red dash line. So I can put green and here I can put comma and use maybe K for black, and I can use dot dashes or dashes dots. So it's just way how to format figure. Oh, my pleasure. So now I'm going to swap the real and imaginary. Put here imaginary, remove X, put here real, and here I do plot 3. Yes, it's my favorite. So if you agree with this image, then and here you see there is a button in different versions of Matlab. It appears in different places, but it calls rotate 3D. You click on it, and then you can watch on this little helical spiral from different angles. So the x-axis is x, and then y, it goes, in my case, from -10 to 10, and then y and z are real and imaginary parts of the imaginary exponential. So I think this is a best visual representation of the Euler equation. I can even label x, label just x, y label real of and z label imaginary. Then I can click edit plot, double click on this space and see if it will cooperate with me. I will not waste time on this, but later on there are additional options to make this figure to look more professional, and if one needs to like make a book or publish a paper, like make like lines thicker and more vivid and colors, tune colors. But right now for educational purposes we are doing great. So I'm going to visit those in class and then ask those online to share screen. So if you got this little spring spiral, it's a great achievement. I think it leaves no doubts about Euler equation, what it and complex numbers. Excellent. Yeah, thank you. Yeah, that's great. Oh, you already did programming. Yeah, thank you. You're 2 labs ahead. Yeah, that's great. That's great. Okay, and where is the figure? Can you rotate it? Yeah, excellent. Huh?
Why is it rotated?
Why it curls this way, not the other one?
Like this spirals are shorter than.
Because mine goes from -10 to 10 and your goes from 0 to 10. If let's click here, look in the command line, arrow up, just arrow up until you see definition of x. Go. X equals this one. And now instead of 0, let's do and now let's watch. Make sense?
Yeah, but also like how can you tell which one is the X, which one is the Y?
X, Y, Z. You can and if you type this little commands for labels, it will make sure that you understand. You can call them just X, X, Y, Y, Z, Z. And then it will show you that this one is X, here will be Y, here will be Z because it's 3-dimensional. Make sense? Yeah, it goes really well. So I'm going to stop sharing and then ask those online to share screen. Joseph, Dieter, would you feel comfortable sharing screen?
Yep. Just give me 1 second here.
Excellent. Thank you. You can stop sharing. Nate, would you feel comfortable sharing screen? Yeah, it's great. Thank you. You can stop. Josh, would you feel comfortable sharing screen?
I mean, something seems a bit off, but I'm trying to figure out where.
It's great. Everything is correct. I think when users online version, it makes some tricks to us, but I see it as a correct thing. Yeah. Yeah, always great. Thank you. You can stop sharing. What else do we have for today? So we are done with complex numbers and plotting exponential graphics functions. So let's do just a little differentiation and integration. So if I return to 2-dimensional plots, plot cosine x, or even plot x squared, then let me do the following. Okay, so what is a derivative? Change. Would it? Yeah, I think. Would you see if I right here? Just don't want to change the plan. So dy dx can be defined as limit of y x plus delta x minus y of x divided by delta x, right? So it means if the function is represented as set of discrete points which are offset by delta x, we just need to subtract the values, the nearby values. Okay. So let me introduce this diff function in maybe even in a simple way. So if I type y equals our simplest example 0, 1, 2, 3, 4, and then I type diff of y. Did you notice what happened? So the elements of this array are 0, 1, 2, 3, 4. Diff means it takes most senior and subtracts next junior. 4 minus 3 will be 1. Then it subtracts 3 minus 2 will be 1. Subtracts 2 minus 1 will be 1. And it will be like constant. We can interpret it if it is a linearly growing function. What's a derivative of x? Yeah, correct. If we just do 0, 1, 4, 9, 16, 25, and then practice diff y, 25 minus 16, 9, here different 7. And if you look on those, they increase linearly, right? So what is derivative of x squared? 2x. whoever stole 2x gets larger credit. Now let's return to this little exercise. So we do have x squared, and then we apply this diff. Then we put x and diff x. I put just another number because, as you noticed before, when we apply this subsequent subtraction, the length of the array is 1 unit smaller. And for plotting, it should be the same length. So I just do a little trick by adding a blank element. And then I do 2x function, which we know from your calculus classes. So this one is plotted with blue, and this one is red dashes. And you see they coincide. So of course, no one needs computer to differentiate x square function. But if it is something more advanced, sometimes we need it. And here I divide by delta x, right? So let me make a visit and make sure that you can do this little exercise successfully. Very good. Probably you use some symbols and they overlap too much. So let's do just dash dash, like this dash symbol without s. So dashes and solid line coincide, right? Yeah, very good, thank you.
What is the end of that line with, and then is it another?
Line width, apostrophe, comma, and then some like 3, 4, whatever the thickness of line, close the round bracket, close the round bracket, shift 0, yeah, enter. Let's see what is going on. The P, instead of period, when it's comma,
Right
use, yeah, arrow up, arrow left, and replace, yeah. Enter. I think it is correcting. Let's hope. Okay. Let me try. Okay. Now let's do comma x, comma 2 times x. Yep. And maybe let's try this line width once again. Oh, it probably should be in the apostrophe.
There we go.
Okay, yeah, thank you. Can I? Thank you. So let's first try the simplified version. Okay. Now, let's try this version. Also works. Now let's also works. Everything is good with color. And then let's try this line width. Line width, comma. I think you were missing the argument. So it should be line width, and then what is the width to give the parameter?
This expression is to like
So, let me just repeat.
I understood the diff part.
So it just subtracts, right?
Yeah.
What if we use square function? So if you do y squared, it will be like quadratic function. Now we took subtraction. 16 minus 9 will be 7, right? So it's just differentiating the this function by elements. We'll give the thing which will be equivalent to derivative.
Yeah, I understand that. What's zero?
Look here. How many elements are here? 1, 2, 3, 4, 5. Right? If you do diff, how many elements? 1, 2, 3, 4. So if we plot x and y, amount of elements in both arrays should be the same.
Oh, yeah, it's zero makes sense like this. So why is this over 0.1?
Because of the divide by delta x. So diff is only subtraction of this function. And if you want to be correct, we need to divide by delta x. Make sense? No, clear?
Okay, 2x is x squared version. Okay.
Make sense?
I'm trying to find the plot now.
But you did all correct. Yeah, thank you. Okay, and now let's do a visit with, I'll stop sharing and do a quick visit with those who are on the Zoom. So, Joseph Dieter, would you feel comfortable sharing screen?
Yep.
Yeah, it's great. Thank you. You can stop sharing. Nate, would you feel comfortable sharing screen? Excellent. You can stop sharing. Josh, would you feel comfortable sharing screen? Excellent. Excellent. I see both solid and dashes. Yeah, thank you. You can stop sharing. Okay, and we are approaching. You finish very soon. So we need integration, right? So what is the definition of integration? It is like if you have the function from like x1, x2 in the limit, we just have a function at point x1 plus function at point x1 plus delta x plus function at x1 plus 2 delta x, and repeat the summation until function at x2, and everything should be multiplied by delta x, right? So the summation of all elements in the array is just SUM. So we can try sum of x times 0.1. And it gives very small number. Why? Because left and right limits are opposite, equal by value and opposite by sign, right? So they subtract each other. So this this number is as small as 0. 10 to the 5 minus 15 is negligible, and if we take integral from like minus 10 to 10 x dx will be x squared over 2 from minus 10 to 10, so will be 100 by 2 minus 100 by 2 will be 0, right? But summation can help us to do integration quickly. I think it's enough for today. We are done the plan for the first meeting. So everyone is welcome to disconnect and depart. I'll stay here and answer any questions. But I think we did more than one need to do in the first meeting. It's really great progress, and I congratulate you with being on the right page. So you're progressing well. Yep. So have a nice evening. Looking forward to you on Friday, and just stop by right now to chat right now if anyone has questions, but it's fully optional. I see someone is typing. Yeah, thank you, Nate. And I'm stopping sharing. And we'll watch. Aha. So Joe, Josh, and Nate disconnected. On is still connected. Huh?
I don't know why I'm still connected.
So it's not you, it's your host.
Because I already showed my computer.
Okay, but I think I can then disconnect myself as well.